Assalamu alaikum. Today I'll be introducing you to our project. This computer engineering COE 546 computer networks design project, and we are tasked to design a topology for any kind of organization or so that we like. But we chose in our group to um, design a topology for a medium sized enterprise. So in this enterprise, we have the headquarters here over here, which has 4 departments. We have the engineering department, which is on VLAN 10, research department VLAN 20, finance 30, and utilities 40. And then we have the ISP on the left. And then we have the demilitarized zone that has 4 servers. And we have the HTTP here. This www can be publicly accessible through the ISP, through the internet. And then we have a firewall here that enforces security between the ISP and the internal, the DMZ and the headquarter network. And then for redundancy's sake, we are using these 2 links in case one of them fails, the other one is there. And then also for availability as well, we are using and reliability, we are using Etherchannel over here. But let me start by showing you the firewall. This is the firewall. Let me show run. If you notice here, we have this interface. We are giving it okay, let's start from the beginning. This is the name of this interface is inside, and this is the one connected to the headquarters. And as you can see, we are giving it a security level of 100% because we trust it 100%. Then outside is the one that is connected to the ISP, and then that one is 0 because we don't trust it 0%. And for the DMZ, we are giving it 70% because there is some level of trust over there. And then if you notice, we are doing some NATing just to translate IP addresses from inside to public so that you can access the ISP properly. And we have some policies over here that are checking some of the packets that are passing. We are inspecting, as you can see, we are inspecting some of these protocols, FTTP, HTTP. Well, this is just the default and it's just for demonstration purposes. So that's it for the firewall. As you can see, it's working also. Then for the Netflow is a technology used to monitor traffic in the network. So we configured Netflow in both these routers, router side 11 and router side 12. So here I'll show you. Run. Okay, so here if you notice, we are doing IP flow egress and ingress. This will tell the router to log the traffic on this particular port. This is G00, which is this one facing the network, the headquarter network. And then also if you notice over here, we are doing this IP export. This is the export destination. This is where it's going to dump all this traffic information. This IP address and at port 9966, which is the port for Netflow collection. And then we are using export version 9, which is the latest version and the most efficient version for now. We have the same configuration inside this router over here, the same, so we would not need to go there because of our time. And then this is the Netflow collector. As you can see over here, this is where you would have to go to access it. The Netflow, it's plotting a nice pie chart for us for all the packets that they have passed the traffic. And then you'll see that it's mostly white because this white is classified as the other types of packets. So any packet that is not IP, an IP packet will show as white, and you can see it dominates the network with about 94.15% of the traffic. And then we have some other traffic here, like this green one is just 0.584. So it's tiny. This is why you can see that it's also tiny, or they are tiny, showing tiny in the chart. Okay, that's it for the Netflow. As you can see, it's working. And then we have the SDN controller over here. The SDN controller is used to manage the network. It can be remotely, you can even programmatically configure some devices, but for us here we are just showing the health level, and we just want to see that it's working. And the reason why we have 75% is because some of the devices we have not configured management SSH telnet, which is what SDN uses to connect to these devices. So we just connected for about just some of them. So this is why it's 70%. Here you can see it's even the host, 70% of them are connected, while for the device is about 40, which is also okay. Well, this is just to show that the network SDN controller also it works. And then this is our core layer, and we are using Etherchannel. This Etherchannel is meant to enhance the availability and reliability of our of this network. And also here you can see we are using the same technology. I'll go into one of these switches and I'll show you how we are. Okay, so here if we show Etherchannel summary, you see that yeah, we have this port, Etherchannel port 0, port channel 1, and it is SU meaning it is in use, and also it is layer 2, and we have aggregated port 104, 105, 106, 107, and 108, and these are the ports that we have aggregated. And then if I show interface brief, you'll see show IP interface brief. You see that this port channel 1 is up, and it is active, meaning that it is working. So our Etherchannel is working. We are deploying the same technology over here, so we don't need to check all of it. This is our core distribution layer, and then for the access layer down here, we have some devices, and these devices are connected to the departments. We are using VLAN. So let me just go into one of these access layer switches and show you the VLANs. We are using one of the multi-layer switches up there for to serve as the VTP server. So this is one of the switches, and if I show VLAN, you see that it has all the four VLANs, and I think we are using this switch for the show VTP. I think status, yes. Okay, yes. So this is the VTP server, and it has all the departments. Show VLAN. Yeah. So this is the switch that is broadcasting the VTP information to all other switches. And here, if you notice, we are using Wi-Fi because now these days computers don't have a lot of modern computers don't even have Ethernet ports, so you have to use wireless to connect. And the advantage of wireless is that apart from it has this mobility advantage, because clients that are connected through wireless can move around with their devices. Their device doesn't have to be static, it doesn't have to be immobile, it doesn't have to be in one place. They can move around with it, so they have the advantage of this mobility. And okay, so this is why we chose to use wireless to connect these devices with these access points. And then we will try to see how we can reach the ISP. I think I have already pinged the ISP on this. Yes, you see that we pinged the ISP. The ISP, this 8.0.0.5 is this server over here. As you can see, its IP address is 8.0.0.5, so it's working. We are able to ping the ISP from this headquarter network. And yeah, I think I've already shown you the controller, that it works also. So that's it. And also we have some servers here, like we have this mail server, and I think I have some emails here. These are some emails that we have sent and they are all working. As you can see, I sent some emails from PC0, from PC2, PC1, Salaam alaikum, and it's all working. And so I think that will be it. And this is the FTP server also. So well, this is the summary of our topology, and if you have any questions or any queries, you can ask us, and we can also provide you with this file. I don't know if we can provide it now because we have not submitted the final project, but anyway, um, you can ask us any questions, and inshallah we'll try our best to answer the questions. This is just meant to be a very short demo, a demonstration of our topology and the kinds of technology that we integrated into it. Assalamu alaikum wa rahmatullahi wa barakatuh. Thank you very much. Shukran.